Hello everyone, this is your junior high school math teacher, and in this video I'll be discussing the second topic under week 3 to 5 in your Mathematics 9. And this is solving related word problems involving right triangles. So upon watching or after you watch the video, you should be able to apply the trigonometric ratios in solving right triangles. And also, you should be able to solve related word problems. And of course, during the class discussion, you should participate actively. Okay. So in this material, you would be able to apply the principles of solving right triangles in solving problems related to angle of elevation as well as the angle of depression. You shall be able to illustrate these two types of angles which are very useful in solving related problems. But in this video, we will focus our attention on just one type of angle, and that is angle of elevation. Now let us start with some examples, some problems related to angle of elevation. And the first one is a man in black. Okay, a man in black agent is standing at ground level 54 meters across the 324 meter Eiffel Tower, aiming his laser gun at the alien. At what angle of elevation should the agent shoot his laser gun? Okay, so for our solution, let us analyze the problem. Now, suppose we have this Eiffel Tower, and from the foot of this tower, there is man in black, which is standing 54 meters away from that foot of the tower. And the height of this tower is 324. Now, in this position, the agent is aiming at the alien, meaning the alien is on top of this Eiffel Tower. So the question is, at what angle of elevation should the agent shoot his laser gun? So this is his line of sight. And the object being observed here is the alien. Okay? So, in this problem, the agent is aiming at the alien at a certain angle of elevation denoted by theta. So what are we going to do? How do we solve this problem? Now for our solution, to determine the required angle of elevation, which is denoted by theta, we set up this trigonometric function. So if we analyze the situation, the given information here is the distance of the agent from the foot of the Eiffel Tower, which is 54 meters, and the height of this tower is 324. And as you can see from this illustration, there is a right triangle formed. Okay? Now, the unknown here is the angle of elevation. The angle should the alien shoot his laser gun. Okay? So, that is denoted by theta. Now, in trigonometry, if this is our reference angle, this 54 degree is the horizontal leg, which is what? The adjacent. And the height of the tower is the vertical leg, which is the opposite of this angle. So, one particular trigonometric function can be used here is what? It's tangent of theta, and that is equal to the opposite leg, which is 324, which is the height, over the adjacent leg, which is 54 meters or 54. So, 324 can exactly be divided by 54, and the quotient is actually what? 6. Okay, so that is tangent theta is equal to 6. Now, from this equation, we transform this, solving for theta, so we must eliminate tangent on the left side. Therefore, the equation becomes what? Theta is equal to, going to the right, it becomes the arctangent of 6. Now, what is that angular measure in degree whose tangent value is 6? Now, using your scientific calculator, you just simply press first the shift key followed by the tangent key and type 6. Then afterwards, you press the equal sign and the value you will get is what? 80.53 degrees, which is the required angle of elevation in order for the alien to shoot the alien by his laser gun. Okay? So this is the answer. Okay? So that is your theta, 80.53. Now our next example is this. A tree 50 meters tall casts a shadow of 60 meters long. Now, what would be the angle of elevation of the sun? Okay, so, of course, we need to analyze first the problem by illustrating this problem. And the way to do that is to draw a simple right triangle. Okay? Labeling all the necessary information. So, we have a right triangle whose vertical leg is 50 and the horizontal leg is 60. And we have the acute angle denoted by alpha. Okay, so actually, from this diagram, you just think of the vertical leg as the tree. Okay, so this is the tree, and the horizontal leg is the shadow of the tree. And the angle of elevation of the sun is actually taken from the tip of the shadow, to the top of the tree. Okay? Now, this is angle of elevation simply because it consists of the line of sight from this point to the top of the tree with respect to the horizontal. Okay? And that is your alpha. Now, as you can see, again, this is a right triangle. Obviously, there is a small square drawn at the corner. And using the trigonometry, let us choose the necessary trigonometric function in order to solve for the unknown. And that is to determine the angle required, or determine the angle of elevation denoted by alpha. So the trigonometric function can be used here is what? Tangent of alpha, which is equal to 5 over 6. This is actually 50 over 60. We just simply simplify the fraction by eliminating the common factor 10 here. Okay? Then from here, we have what? Alpha will now be equal to, of course, tangent will be cleared from on the left side, but when it comes to the right side, we are now getting what? The arctangent of 5 over 6. Okay, actually, this is 5 over 6. Wait. Okay, let us continue at this point. So we have alpha. From this equation, tangent of alpha equals 5 over 6. Transforming this equation for alpha, that will be alpha equals arctangent of 5 over 6. And using your scientific calculator, again, you press the shift or the second function key, then followed by the tangent key, and then you type 5 divided by 6, and then afterwards press the equal sign. You will get the value or the measured angle alpha, which is 39.81 degrees. Now this is the required angle of elevation from the tip of the shadow, so that is the angle of elevation of the sun. Okay? Okay, so this is the angular measure of alpha in degrees. Next, we go to the next item or next problem. Okay, for our third example word problem, we have a ladder leans against a wall, forming a 60-degree angle of elevation with the ground. If the base of the ladder is 5 meters away from the wall, how high does the ladder reach on the wall? Again, we analyze the problem by preparing an illustration. So for our solution, now this is the analysis. Suppose we have this horizontal line segment, and this represents the ground, and the vertical line segment, which is the wall. Okay, and let's just say that this is the ladder that leans against this wall. And according to the problem, the ladder is, okay, form an angle of elevation with the ground which is 60 degrees. And the foot of this ladder is 5 meters from the wall. Okay? Of course, there is a right triangle involved here. Now, there are two given measures here. This angle and the distance of the foot of the ladder from the base of the wall, 5 meters. So, from the figure, we are asked how high does the end of the ladder reach on the wall. So, from this right triangle, we are actually looking for the vertical leg of this right triangle, which is denoted by H. So, this is the required unknown. Okay? So, for our solution, of course, again, the required unknown here is H. And this symbol denotes what? The height the ladder reaches the wall. Now, for our solution, we need to set up the equation, and we are going to choose the right trigonometric function to solve for the required height, or height the ladder reach on the wall. Okay, so, and that is tangent, because with reference to this angle, which is 60 degrees, 5 meters is the adjacent side or leg, and the unknown is the side which is the opposite of 60 degrees. Therefore, the function to be used here is tangent of what? 60 degrees equals h over 5. And then we solve for h from this setup equation by simply transforming this equation, solving for h, and that will give us this equation. We can now immediately determine the value of tangent 60 degree. It's either you use scientific calculator, or if you remember the value of tangent 60 degrees, which is in terms of a radical, that is actually square root of 3. And then copy the remaining part of this equation. So that is square root of 3 is equal to h over 5. Then you do the cross product, multiplying 5 by the coefficient of square root of 3, not the 3 from the radicand, which is the radicand. That is not correct. 5 here must be multiplied by the coefficient of square root of 3, and that is 1 on the left side. Okay? So, h is actually the product of 3, square root of 3, and 5, and that will give you what? H is equal to 5 square root of 3, or, okay, that is meters, or if you want to evaluate, you use the equivalent of square root of 3, that is 1.732, and multiply that by 5. Therefore, your h can also be equal to what? 8.66 meters. So this is how high the end of the ladder reach along the wall. Okay, so it means this height here is this value, 8.66 meters. Okay, and later on I'll give you the assignment relating to this discussion from this video.